for example, is 1 over n plus 1. What would be the upper bound for this? Can we find the upper bound of this number? Yes, 1 would be the upper bound for this. Because I know that n plus 1 is bigger than 1. So 1 over n plus 1 is going to be always smaller than or equal to 1. So this is going to be always smaller than or equal to 1 for all n. Why? Because, do you agree that n plus 1 is bigger than or equal to 1? You take any natural number, it's not bigger than, but it's strictly bigger than 1. Okay? And then you take the reciprocal, smaller than 1. You have this. So like this sequence is bounded by 1. Can you tell me why this sequence is not convergent?
It is not bounded.
In the light of this theorem, you can argue that you cannot find basically an upper bound for this sequence, and hence the sequence is not bounded, so can't be convergent, because the boundedness is a necessary condition for this sequence. But basically, do divergence, would define divergence precisely. But I'm just telling you that how these little observations are, very interesting one actually. So let's try to prove this result. Okay. So what we need to assume, so we're going to say that let Pn converges to P. ठीक है? Pn converges to P. No. If you are taking absolute, so it means that this m is not only bounding it from above, it's bounding it from below as well. Because what does it mean? Pn, absolute of Pn is smaller than or equal to m, means that Pn is between minus m and m. So the lower bound is minus m and upper bound is. Midpoint. हमेशा बाउंड हो, it's a good intuition. It's a good intuition. It's not going to be the limit basically. One need to be careful. Limit point is different from limit actually. Okay, these two things are a bit different. Okay. Convergence के sense में वो different. So we need to use appropriate terms. One thing. But for the boundedness of a convergent sequence, yes, limit plays a role. We're going to see this actually. There is going to be limit plus something else, which is going to work as a power basically. So converges to P. So what does it mean? For epsilon positive, we can always find a natural number such that Pn minus P is the distance between Pn and P is less than epsilon whenever n goes beyond this capital N. Let me explain this first for basically, in case of rails, it's going to be much more easier to grasp. Let's think about it for the rails first, and then we can think about the metric space. I mean, we bring a similar argument for metric space. You can do it for yourself. So if you have this, what does it mean? Can I say that from this I can follow that this my Pn minus Pn is smaller than P plus epsilon and bigger than P minus epsilon. Agree with me? So it's like this implies that Pn minus P is between epsilon and minus epsilon, and then you add basically P to it and n bigger than or equal to n. Okay. what should we do?
So,
We have one trouble at. After n, we know that this sequence is bounded by this number. Can you see that? It's bounded above by this number. But the question is, what would be the case
before
the n? So what should we do? What should we do? We have to reach to basically this definition.
We have to find m.
Mn. What do you think that, what should be that m?
Sir, it means after n greater than n, we have sequence bounded. But we are thinking now for less.
एक इन ऊपर लेके आएंगे जो मतलब सेलिस होगा तो वो होगा माइनस पी माइनस लेस होगा.
Let's think about this. I'm defining this. I'm saying that m is the maximum of the distances between absolute of say p1 plus epsilon, p2 plus epsilon, and up to Pn, not n but say for example n minus 1 plus epsilon, okay, and say for example absolute of p plus epsilon. Let's take the maximum of these numbers. Do you think that why this maximum is going to work for the both cases? Think about it. So after n, I know that this number is a number, okay? But before n, I have all these numbers. So it's like this, this, and this. So I'm saying that take the maximum of these basically, including this. So the maximum of this is going to be not only bigger than all of these terms, but is going to be also bigger than this number, and hence all of the pn's actually. Is it making sense?
So why are we adding epsilon? I mean, we can have this upper bound or this total bound without epsilon also.
Why?
It would be greater than or equal to P1 or greater than or equal to P2.
So you want this actually?
Yes.
Okay. Okay. Is it fine now? Can you see what's going on? So my point is this, that you have this number absolute of p plus epsilon, and you have all these n minus 1 terms. So I'm saying that this absolute of p plus epsilon is bigger than all of the term after this n, and for before this n, I can not only for before but like for all actually times, I can take the maximum of these numbers. So that's a finite set, because there are going to be only finite terms before this capital N, and for this finite maximum must exist actually. We know that, least upper bound property, okay? Greatest lower bound property, maximum minimum दोनों होता है, ठीक है? So you can find a maximum. Imagine this P1 is maximum. What does it mean? P1 is bigger than all of the term up to Pn minus 1, and it is also bigger than this number. So if this is bigger than this number, so P1 must be bigger than Pn as well. So what does it mean? That before n minus 1, P1 is bigger, and after n, so n and afterwards n, since P1 is bigger than this number, so it's bigger than all of the terms actually. and hence you're going to say that this m is going to. So give me an intuition. I'm going to try to write a precise proof. Okay. There are shortcomings. I can criticize this, but it's a fun proof. Okay.
Sir, maximum इसी सेम में से ले रहे हैं तो वो एप्सिलॉन ऑफ p प्लस
देखिए.
इससे ग्रेटर केस में
Can you see from here that if I take the absolute of this is going to be smaller than absolute of p plus absolute of epsilon. ठीक है, यानी यहाँ से ये follow कर रहा है कि absolute of pn is smaller than absolute of p plus epsilon. ठीक है, for all n bigger than or equal to capital. ठीक हो गया. और मैं अगर absolute ले लूँ, so I can apply triangle inequality on this side and I will have actually this. Okay? So my point is this way. After this n, इस n के बाद I know कि सारी terms जो हैं, for example, imagine this term is 100. 100 के बाद सारी terms इस number से बनी है, fixed number से. I want to find a number जो कि न सिर्फ 100 के बाद वाली टर्म से बड़ा हो बल्कि 100 से पहले वाली टर्म से भी बड़ा. ठीक है, तो वो जो नंबर होगा जो 100 से बाद वाली टर्म से बड़ा हो वो इससे बड़ा होना चाहिए. इससे बड़ा होगा तो तभी करेगा मेरा पॉइंट. और वो जो 100 से पहले वाली टर्म्स हैं उनमें से हम उससे भी बड़ा होना चाहिए, उन सब से भी बड़ा होना चाहिए. अब सवाल ये है कि उन सबसे में बड़ा तो मैं ये कह रहा हूँ. So I'm saying that take P1 and P2 and Pn minus 1, which is like 100, and this number, absolute of P plus absolute, and take a maximum of this. Just think about it, why this maximum works. Imagine यही number सबसे बड़ा. What does that mean? That this number is not only bigger than after n, but it's also bigger than all of these numbers. And hence, this m is bigger than all n, for all n. But imagine that this is not a bigger number, but this is a bigger number. What does it mean? Then this p1 is going to be bigger than or equal to p1 itself, and bigger than p2, and bigger than p3, and bigger than pn minus 1, and bigger than this pn. So the P1 is bigger from P1 to Pn minus 1, all, it's like before n. And since this P1 is bigger than this absolute of P plus epsilon, so it is going to be bigger than all of the terms afterwards. Okay. So when you will take the maximum, that is going to work, it is going to be bigger than all of this here. So that's what the logic. It's a bit trickier, but it's not that difficult. ठीक है, I would like to finish that proof and I would like to finish it, finish the discussion. So now I can basically argue that since this sequence an is convergent, okay, so I can say that since an is convergent, so there exists m such that absolute of an is smaller than or equal to m for all n. Okay? So in other words, my terms now become n independent. That's what I want. And hence I can say that this distance is smaller than or equal to absolute of m, or maybe m times bn minus b plus absolute of b and an minus a. Okay? Is it making sense? Now what changes should I make here? Or make here in order to basically get an epsilon. So I will say that divide this by 2 and m and divide this by 2 and absolute of a. Or absolute of b, sorry. Okay? And in this case, I can say that this number is bigger than epsilon by 2, and this number is bigger than, smaller than epsilon by 2, and smaller than epsilon by 2. So their sum is going to be smaller than epsilon, and hence this sequence converges to A, where A and B both should be, non-zero. Should be non-zero. But instead of choosing A and B, I can choose A and B, A and B and B. Anyway, so finish up this proof, the rest of the part for yourself, and we can end our discussion here. What will be the benefit of this? If I basically quickly tell you, imagine I have a sequence like 1 over n power p, okay? Where p is some quantity bigger than 1, n power p, where p is some quantity bigger than 1. What do you think that to which it is going to converge? It is going to converge to 0. So we can write a proof for it. Okay, I can show that for epsilon positive, I can choose n to be 1 over epsilon to the p, or maybe 1 over p, something like that. And if you choose this, this is going to show that. Now, using this result and the algebra of result, I can prove very complicated result. Imagine I have something like this. So n cube n square plus 3n plus 5 over what? If over what? For example, square root of n. Something like that. Okay? Square root of n. No, not a square root. Square root of n is not going to work. Imagine I have. Okay, I have this. So say that's n cube plus 2n square plus n plus n 6, for example. I'm just making this up. Okay. And I say that prove this for me that this converges to some number. Now how the heck I can know that it converges to some number? And you see that it will be very difficult to apply basically definition here. For every epsilon finding n is going to be a nightmare. But I can play something very simply. Just think about it. If I take n square outside and divide by n cube, so I'm gonna have 1 plus 3 upon n plus 5 upon n square over n times 1 plus 2 upon n plus 1 upon n square plus 6 upon n cube. Is it making sense? Now, why this series is convergent? Because I can say that 1 is a constant convergent, 3 over, so it's like 1 over n is convergent, it's converging to 0. But when you multiply it by 3, so it's also convergent by this result. And 1 over n square is convergent from this result. So p bigger than 1. So you multiply it by 5, it's also convergent. So if this is convergent and this is convergent, the algebra says that their sum is convergent. Are you getting the point? And these, by this essentially same argument, these 4 series is also convergent. So if these 4 series are convergent, then essentially by what do you say? J.
But आप n cube कमा निकालते हैं, but आप n cube कमा निकालते हैं.
No matter how you do, doesn't matter. But what I want to show is that for such a complicated expression, there is no need to play epsilon delta game or epsilon and game. So I can use algebra and, for example, this result, which is going to be very helpful, and I can easily, directly argue. Okay?
We said 1 upon n square by this result is convergent. 1 upon n square is
Yes, it is
convergent by this result, sir.
Yes, why not? Because P is bigger than 1. So 1 over n to the P is n to the power P. It's a power P. I don't know that whether you understanding it and ठीक है? Is it making sense? So wish you good luck. Work out on that. I know that I took lots of your time, but I wanted to spend this time so that we can have a discussion after this. Make classes, do arrange classes.